Hello everybody, in today's video I want to share with you one of the best practices for the beginning industrial designer. With this exercise you can improve your design skills on multiple levels at once, right? If you apply it, you will improve your understanding of how things are being made in terms of manufacturability, what to pay attention to. You will learn how to solve real problems that are actually relevant for your products and that are actually coming up during the design process in real life. And the best of all, you will end with a design that is yours and all yours and that works completely, that you can use, that you can show around, that you can use on a daily basis, take to your interviews, whatever. So with this method, you will learn everything that you need to know, all the necessary skills to bring something from an idea all the way to a final result. So if you're curious how to do that, stick around and let's go together. All right, let's go. So the method that I'm talking about is building your own product. And obviously that's really difficult, right? From zero, from scratch, whatever. But we don't have to start from zero. There are loads of existing products out there. So just go to the next thrift shop, to the next $1, euro, whatever shop where you find something rather cheap. There are so many really cheap products, even electronics out there for a couple of euros or dollars. And you can just buy them off the shelf, maybe even two, take them with you and look at them to understand how they are being made. Take the internals, all the electricity, all the buttons, all the functionality, and ideally you have your own 3D printer. You can take all the measurements, create your own design vision, and install these internals into your own 3D printed housing, and then you will end up with your own product design, right? So as an example for today's video, I bought this humidifier. Like, it cost 8 euros, so it's not all that expensive. At the moment we have the heat wave in Europe, right? So I thought maybe it's an interesting approach. It's quite small and compact. So I think there's a lot to do here that we can improve and see where we go, right? So the first thing that we need to do is we need to disassemble and understand how this object was being made, right? What manufacturing technologies were at play here? How can we identify them? What else do we recognize? What about printing? What components do we have? How do they interact and work together? What's the overall mechanism that is at play here? So all these things require us to take a deep look at this, disassemble, and understand the whole thing for ourselves. So here it is. This is the humidifier. We see it has this wood optic. It has this tight neck to touch. Here we also see it working. So all it has is a button at the front, right? We have a base with some pattern in there, and we have the exit for the vapor or the water droplets. And that's basically all we have. We have one switch to turn things on, and we have one power source, and that's all there is externally in order to run this. So that's also cool. Right now we actually get to understand how this works in terms of what kind of mechanism is behind it, what kind of technology is being used in order to create this humid air, this vapor, these droplets, right? So it's so much that we can take from just looking closely at these objects around us. Now let's take things apart. So this is our body as it comes, right? Then we have this wood texture on our entire part. So I think it's most probably water transfer, right? Because water transfer you can really use for also organic shapes and still get everything covered in your desired appearance. I think the base plastic is brown plastic, and they just add like these, but the wood grain on the water transfer. So how water transfer works is basically you have water, and then you put a layer of your desired print onto that water, and then you more or less just dip the object slowly in there so the print has time to wrap around all the surfaces equally. There's also some common problems with water transfer, but the way I look at this, I really feel like this is most likely water transferred, especially also because the pattern wraps across the top edges, right? So if it were to have a heat transfer foil, then they would probably just go all the way to the edge and not over the edge and across. It makes things really hard because then you would have these annoying creases here with the foil, and that would result in problems. So this, in my opinion, is water transfer. So the first thing we learned is that maybe this is water transfer. Obviously, we never know for sure. Yeah, we can make guesses. Also, just take a picture, ask ChatGPT, but common options are there for humidifiers. And if you find any problem spots like here, right, show it to ChatGPT or any other AI of your choice and ask them what this may indicate. Is this actually water transfer, or is there other options that we haven't considered? So let's see. So we have two halves, right? The bottom and the upper half, and both of these halves, they also have another white, semi-transparent, semi-opaque part inside them. Now we have this little spring thing that was interesting to me. So there's a spring and also this cotton swab, or this little pillar, this little stick, cotton stick, that is basically pushed into against the mesh that we see at the top of our design. Now I unscrewed the whole thing, so we actually can take a look inside, and what we see is that there's a very simple PCB. There's our mesh that is connected to the PCB. It is straight connected to the power input, and we have a cable running to the switch, which is like, it looks like just a copper sticker. So it seems like it's just working based on conductivity, right? So if we just get close enough, because there's no press action, there's no mechanical action of this whole thing. But basically what we also see is that it's definitely injection molded. We do see the classic marks for ejector pins here. We have some separation line going on around the top edge. In this one, we can presume that the mold released like this, top and bottom. We have equal wall thickness mostly, and we have some funny inner scratching. I'm not sure what it is exactly. But yeah, and same goes for the top. We have a bottom and top, but here we have an undercut, right? So how is this then made? We have two halves, and then we have an additional one coming from the top and the bottom. So this is a more complex mold than for the bottom base, right? Because we have more parts, more moving parts especially. But that's the only way how you get these undercuts that's nice and smooth without any further complications. And here too, we do see the ejector pins and some additional roughing. I guess they either try to fix some of the stuff that was left after they took it out of the mold by sanding it down, or indeed the opposite is the case. They were straight out of the mold. So all it took was 3 screws. Then we see in the white part also that they were also injection molded, and then they included a bayonet mechanism to connect the two pieces. All right, now it's time to actually go in there and design your own idea, your own product, right? So now you understand, you have a basic understanding of how things work. You decided which components you want to keep and which you want to drop, and now you have a reference, you have a real life reference. Now you can go in there, make all the measurements, bring them into the 3D to make your own design, fit those measurements, and then start with test prints. Prototype as fast as you can to get like quickly feasible results. So in the end, you have something that you can actually show around. So at first I start by modeling reference geometries that I have a digital copy of my objects in the real life, in the digital world, so I can much more easily find the appropriate connections and diameters and so forth, right? So I start by building a simple base, basically just a cylinder, right, with the right wall thickness that fits the part that we already have. I see how to mount it, so I print these mounting plates in different variations. At first I thought I can just integrate it with the main shape, but then this made it really difficult to install actually, the PCB and everything. So I decided to make it a 2-piece design that I first attach here and then just use the bayonet connection to basically install on the main body. And that's how I basically proceeded throughout the entire process. Here are all the parts. I printed several small sections before I printed the whole thing in order to test stuff, right? So this is the base with the water reservoir that I kept. Then we have the different mounting plates that I tested with the bayonet, integrated then without it, right, as a separate part. Then this is basically the plate where I wanted to test how thick can I make the wall for the switch to actually work, and I figured that it doesn't work at all, but I noticed that if I just touch the cable, that's enough. So I basically defined a new switch. Here we have the intersection piece between the top and the bottom. I also had to figure out the right hole diameter for the screws to fit, because it's like plastic screw fit, right? Then this is the PCB as it's installed. Basically at the moment in this prototype, the cable is basically just holding the entire PCB, which is connected then to our membrane, and the switch that I developed, the design is basically just run the cable through the wall, back inside, and then I can just touch the cable. Now I more or less can assemble the whole thing and apply power to see if it works or not. I forgot to actually put holes in my lid, so I just roughed it in. But I can close it completely, so it's sealed, or I can open it and have the vapor come out. So this is how it looks when it's running, right? So we have this really nice and smooth. That's what I like, not the aggressive fountain, but more the vapor that goes to the side. It looks a little bit less, right? There's less vapor when I do this passive way. So I can also just remove the lid if I want to keep the main style, the pressure fountain. But I have to say that this one turned out pretty big, right? I made it larger, but because I was confined by the circumference of the parts that were already there, I could have gone to the top a little bit more slender, but I feel like I should do something else, right? So I looked up and there are these other ultrasonic vaporizers. It's just a single component that I bought off Amazon because I felt like, okay, I want to take this a step further. But new part also means new challenges. So here you can see all the different models that I did for this version of the humidifier. One cool thing that I thought I'd try is basically creating a design pattern, applying it to my geometry and Boolean reducing it from my main volume. So I have thinner walls in a pattern. So when I put a light in it, that it's supposed to show that pattern only when the light is on, and if the light is off, that you can basically just see it as a normal thing. So it's like a hidden little surprise effect once you turn the whole thing on. But yeah, you basically see all the different variations that I tried for this version. I feel like aesthetically this is much more what I am looking for. Also in terms of size, it's not as big. At the same time, I have as much water as I had in the other one. And I just don't have a switch, but I could have bought one and just installed it with it. So apart from that, I feel like this is the next iteration, right? So here are all the different lids that I designed, but also I noticed with this ultrasonic vaporizer that it would always splash upwards. So I had to find ways to reduce the amount of splashing, but if I cover the whole thing, then there's basically no vapor exiting anymore because there's no pressure difference or no wind that would actually push out the air. And here's the effect that I was talking about with the LED. Unfortunately, you can see a lot of the actual 3D printed geometry, which is not the pattern. And you can see in real life much better how it actually looks like. But hey, it was a test. I think this is a cool effect that I will definitely test out further for future products and iterations and stuff like that, because it's nice, like this hidden feature. But apart from that, here you can just see all the other things that I printed to test to see what works best, what doesn't. Can I just keep a hole in the center at the top? Or what if I shift it slightly off center so it doesn't splash water out as much? Right, so all these things I had to consider. And this is now basically the final result that I ended up with. I think it looks really cool because it looks like a solid, smooth, monolithic shape from a single solid. I have this mouse hole at the bottom for the cable, but actually you can remove the lid. So you have a fountain, more or less, look inside, or you can remove the upper half of the whole thing and just place it on top. So we get this subtle kind of effect again for the vapor to just drop from the sides instead of the top. So here we have it. Let me remove the lid, the top, and you see already it comes out. And it's almost like it's flowing outside. It's like also rather subtle, like not going crazy, but I like the effect. It's like a little waterfall running down my own humidifier. So it's more decorative than actually functional humidification, right? But also when I move the whole thing, because of the pressure differences, suddenly the vapor goes everywhere. And this is actually fun. So I was also thinking if I should just connect a motor to the whole thing to have a movement in there to basically just shoot these vapor rings in the air. It would also be cool. Here you can see the splashes, but that would have gone too far. But also that's a really cool thing, right, about these kinds of projects. You play with something, you get new ideas, you figure things out, you can decide if you want to go that way or not, but at least you have something in your mind that can be handy also for all kinds of other projects. So not only apply to this project by itself. So all in all, this was the process of how I think many beginning designers can really boost their games and understanding of how things are made, how to solve real life problems in terms of how to measure things, right? Even if they're not typical geometries, how to connect them, the different pieces, how to assemble things. Also, like how often, I mean, it still happens, right? So I made the top, but I forgot to cut holes in the top for the vapor to exit. So those things you only notice when you actually go out of the digital world into the real world, print your own stuff and figure things out. And in the end, I think it's pretty cool that you have something that you can show around, that you can place on your shelf and tell everybody that you did this. I think it's cool. Why not? All right, this was it. I hope you enjoyed it. I hope you were able to learn something, and I would love to see you try this approach to up your industrial design game. Just get out there, buy anything like a Bluetooth speaker. They cost maybe $10 nowadays. Headphones, like a computer mouse, whatever it is. It doesn't have to be electrical either, right? It can just be anything. You can get a spoon, but the handle is shitty, so maybe make your own handle for your spoons. Like all these things, just go through a shop, take $10 or euros, and buy something to reinvent it, solve a problem, and make it your own. I hope you enjoyed it. If you did, follow, like, and subscribe for more. Thank you very much.